Hello, my people. Good morning, good afternoon, good evening. I am Tasen and I'm happy to be here again. Welcome to Matify Analytics. I'm happy to help. I'm here to serve. Yes, some people are asking why I am actively solving these equations. As you can see at the board here, I have question number 20. Where is question number 19? Where is 18? Where is the other questions? We have been solving these questions and they were questions for a national examination that was done in Rwanda last year. It was a national examination for grade 2 students who were completing their high school education, and it was for many options in Rwanda. So if you know anyone who is learning MCB, who is studying MCB option and the MCE, MEG, MPC, MPG, and PCM. So let them that we are here to help. I'm solving these questions not for me, but for you, for the sake of my community, for the sake of the generation of my country. I want the students to understand how the exam is structured and how to answer the questions so that they get ready for the examination. So let them know that we have the questions solved here for them to come and learn. So it's up to you. You can share this video. Please help me to share this video to your friends, to the students that you know, that they can benefit from these videos, because these videos are not for me, it's for you and for the generation, especially Rwandan youth, Rwandan generation. Let them that we are here to help them. But hey, if you are watching from another country, this is mathematics and the mathematics is universal. I hope you are also going to learn from our video, especially this equation. This question is dedicated for people who want to understand how to compute the mean, the variance, and the standard deviation of a random variable given its probability density function. Because in this question we have been given a probability density function f of x, and in the function we have a parameter and an unknown parameter constant a, and we have to compute it, and then we are asked to compute the mean, the variance, and the standard deviation of this random variable. So if you want to know how to, please watch this video from start to the end. If it's your first time to be on this channel and you wish to see more videos like this in the future, don't forget to subscribe. Subscribe to our channel and remember to turn on the notification bell so that you will get notified anytime we upload a new video. And of course, if you like this video, don't forget to click like the video and share the video to your friends. So let's start. Alright, so we have our probability density function to be f of x equal to ax times x minus x squared when x is between 0 and 6 and is equal to 0 elsewhere. And then we are asked to first compute the value of a. In a, we are asked to calculate a. So how do we calculate a? The first thing that we have to know is that the sum of probabilities of a random variable should be equal to 1. So if, for instance, we have a discrete random variable x which takes values x1, x2, up to xn, so the assumption says that the sum of probability that x is equal to xi and I from 1 up to n, or the elements, this should be equal to 1. And this formula is used when we have a discrete random variable. But for our random variable x, we don't have a discrete random variable. We have a continuous random variable. So since we have a continuous random variable, this sum is going to be to turn into integration, and we have to integrate from to for all values of x. For all values of x, and what do we integrate? We integrate this probability density function f of x, and this probability density function, when we integrate it, this should be equal to 1. So we have to rely to this assumption in order to be able to calculate the value of a. So what are we going to have if we compute this integration? We have to integrate for all values of x. So we integrate between 0 and 6. And what are we going to integrate? We integrate a x times 6 minus x squared dx. And we should add integration from 6 to infinity. But this time here we have 0 because our function is equal to 0. Then when x is outside this interval, outside the interval 0 to 6, so here we have 0, and this part will be equal to 0. Yes, so this will be equal to 0, and the remaining part will be equal to 1. So what do we have? We will have integration from 0 to 6 of a x times, when we expand this 6 minus x squared, this will be equal to 36 minus 12x and plus x squared, then dx. I think you all remember this relationship. This is something that everybody has to know. A minus b squared, or let me say plus or minus b squared. This is equal to a squared plus or minus 12. Not 12. Where do I get 12? Because I have I have 6 there. So plus or minus 2ab and plus b squared. This relationship, we have plus here when we have a plus sign, and when we have a negative, then we have negative minus 2a. This relationship, this is the identity that everybody should know, and we have used it to expand this 6 minus x squared into this one. All right, okay, so let's go. And this integration will be equal to, I take a black color. All right, this will be equal to 1. So this is a, because a is a constant, I can take it outside of the integral. Then we integrate from 0 to 6. What do we integrate? I'm going to take this x and multiply it with that value in parentheses. Then we have to integrate 30x and minus 12 x squared plus x power 3 and dx, and this should be equal to 1. This should be equal to 1. Let's take this one a little bit up. All right, yes. And then what do we have? We have that a times, we integrate, this will be 36 over 2 times x squared minus 12 over 3 times x power 3 and plus 1 over 3 x power 4, and then we evaluate this from 0 to 6. This should be equal to 1. All right, so this is a times 36 over 2, this is 18 times 6 squared and minus 4 times 6 power 3 and plus 1 over 3 and times 6 power 4 and minus when we substitute x by 0, then it will be 0 minus 0. I don't write it. Then this is equal to 1. When we compute this, you can take a calculator and compute it, then this will be equal to 108. Then 180 times A. This is equal to 180. Take a calculator and calculate it. So this will be equal to 1. And finally, we will get A to be equal to 1 over 108. This was the value of A that was asked. And now I think you know how you will proceed when you will be asked the question like that. That's how we proceed. And in B, before going to B, we can rewrite our probability density function now. Our probability density function f of x is equal to, now we substitute A by its value, then A is 1 over 108 and times x times 6 minus x squared, when 0 is less than or equal to x and x less than or equal to 6 and 0 elsewhere. And this can be written, I want to expand that value in parentheses to have f of x, which is equal to 1 over 108 and times this will be 36x minus 12x power 2 and plus x power 3, when 0 is less than or equal to x less than or equal to 6 and 0. I have expanded it like this so that it will be easier for me to compute the values that we have been asked in the next questions. In the next questions, we have been asked to compute the mean of our random variable x, the standard deviation, and the variance and the standard deviation. In B, we have been asked to compute the mean value, mean of x. And the mean of x, how do we compute it? The mean of x is the same as expectation value of our random variable x. And the expectation by formula, it is integration for all values of x times f of x, then dx, like this. Where this f of x is the probability density function, but normally in main books the probability density function is written with f of x instead of this big f of x. But I'm using this f of x because this is what we have been given, but next time it's better to write it this way, because in many books the probability density function is written like this. But anyway, it doesn't matter. What matters is that we know what we are dealing with. So our expectation value should be calculated using this formula. All right, then what do we have? Let's go ahead and compute it. Expectation of x will be equal to integration from 0 to 6 of x times f of x, and f of x is 1 over 108 times 36x minus 12x squared and plus x power 3. Yes. Then dx. So you see, then this one will be equal to 1 over 108 times integration from 0 to 6 of 36x squared and minus 12 x power 3 and plus x power 4. Then dx. When we integrate this one, what are we going to get? We will get 1 over 108 and times, this is 36 over 3 times x power 3 minus 12 over 4 times x power 4 plus 1 over 5 times x power 5 and this should be evaluated from 0 to 6. We evaluate it from 0 to 6. So this will be equal to 1 over 108 and times 36 over 3. This is 12. Then times x is 6. Then times 6 times 6 power 3 minus 12 over 4. This is 3 times 6 power 4 and minus plus 1 over 6 times 6 power 5. All right, when you compute this one, you can take your calculator and calculate this value, and the final value you will get our expectation to be approximately equal to 2.4. So this is the mean value. The mean of our random variable x is approximately equal to 0. No, not 0. Where do I get 0? Approximately equal to 2.4. All right. And next, we have been asked in B, we have been asked in B2I to compute the variance. The variance of our random variable x. How do we compute the variance? Do you remember the formula? When we have this kind of question, to calculate the variance, I prefer using this formula. The variance of x is equal to expectation of x squared minus expectation of x and squared. Yeah, I prefer using this formula. I think you know how to derive this formula. If you don't know how to derive it, write it in the comment section so that I know that I will have to talk about it. And if you know it, click like, and let's move on. Yes, so what we have to do first is to calculate this value, expectation of x squared, and the expectation of x squared is calculated the same way as the expectation of x, and instead of using x, we use x squared. So the formula is the same. We compute the expectation of x squared by computing this integration for all values of x squared, then f of x dx, like this. So this will be equal to integration from 0 to 6 of x squared times our f of x, and our f of x is 1 over 108 and times 36 x minus 12 x squared plus x power 3. I think you remember the function, probability density function, then dx. So this is it. So then this will be equal to this is 1 over 108 times integration from 0 to 6 of 36x power 3 minus 12x power 4 plus x power 5. Yes, and dx. All right, so this is equal to 1 over 108 of this is 36 over 4 and x power 4 minus 12 over 5 x power 5 plus 1 over 6 x power 6, and this should be evaluated from 0 to 6. All right, and this is equal to what? This is equal to 1 over 108 and times 36 over 4. This is 9 times 6 power 4 and minus 12 over 5 times 6 power 5 plus 1 over 6 times 6 power 6, like this. And when you compute this, of course, take your computer or your calculator and just calculate it. Take your calculator and calculate it, and you will finally get this to be equal to approximately 7.2. So we have expectation of x squared equal to 7.2, and then therefore the variance of x will be equal to expectation of x squared minus expectation of x and power 2. So this will be equal to 7.2, and you remember the value of expectation of x, it was 2.4, then squared, like this. And when you calculate this, you will get the variance of x to be approximately equal to 1.44. All right, so that was it for the variance. And finally, the last question was to calculate the standard deviation. The standard deviation. Standard deviation of our random variable x. Deviation of our random variable x. How do we compute it? The standard deviation of our random variable x is equal to the square root of variance. This is the formula. When you calculate the standard deviation, you calculate the square root of its variance. So the standard deviation now will be equal to square root of 1.44. So we have the standard deviation of x to be equal to square root of 1.44, which is equal to 1.2. And that was it. Standard deviation of x equal to 1.2. All right, I hope you have learned something from this question. Now you understand how we can calculate the mean, the variance, and the standard deviation of a given random variable once we have its probability density function. Don't you like this video? If you like the video, click like and share the video to your network. Please remember that these solutions are not for me. These solutions are for you or for your friends who are preparing for their exams or who are willing to learn these basic concepts of mathematics and statistics. So remember to share this video so that we will reach as many people as possible. Thank you for watching, and I hope to see you next time. And hey, if you have not yet subscribed and you wish to see more videos like this in the future, remember to subscribe to our channel and turn on the notification bell so that you will get notified anytime we upload a new video. Ciao, thank you for watching.